Hello everyone, this is Srikanth. Now I am going to explain you about the topic spanning trees. Let's see what is the meaning of the terms spanning and the trees. Let's see. These are the topics: introduction and the graph and the subgraph and connected graph. Before learning about the topics spanning trees, we should able to learn understand the terms. These terms subgraph, graph, subgraph, and connected graph. Let's see the first introduction of the topic, that is spanning trees. Here you can see a connected subgraph S of graph V comma E is said to be a spanning tree if and only if it satisfies the following conditions. S should be contain the graph S should contain all the vertices of G, means the graph G, the subgraph the let's see the subgraph S should have the vertices all the vertices of graph G. This is the first condition. Let's see what the second condition is, that the subgraph S should contain all the V minus 1 edges, means for example, if the first graph G has four vertices, then it should have four vertices in subgraph S, and in the subgraph S should have the V minus 1 edges, means 4 minus 1 3 edges. Here you can see the example. Here the graph G has three vertices A, B, C, and the three edges A, B, B, C, and C, A. Here means this is the spanning tree because it have the let's see first condition. S should contain all the vertices of G. Let's see A, B, C. Okay, A, B, C. The first condition is true, that all the vertices of graph G having this subgraph, that is spanning tree. And S should contain V minus 1 edges, means here there are 3 edges, means 3 minus 1. 3 minus 1 2 edges, so this is a span tree. Here also same, C to A to B, 2 edges, and I have the same 3 vertices A, B, C. Here also A to C and C to B, 2 edges, means V minus 1 edges and V vertices, means the number of vertices should be same and the edges should be V minus 1. Then we can say that it is a spanning tree. And the one more important thing is that it should be connected. Let the connected graph. For the better understanding, let's see about the terms. You are able to understand the terms connected. What is a connected graph? And you can see here that there are terms like subgraph, graph, and spanning tree. You are clearly clear and crystal able to understand about spanning tree. You should have a minimum idea, basic understanding about these terms. What is the meaning of the connected graph and subgraph? Let's see what is the meaning of the word graph, and what is the meaning of the word subgraph, and what does the meaning of connected graph. And then you can able to understand what is the what does the meaning of the term spanning tree and the concept spanning tree. You can understand very clearly. Let's see what is the meaning of this graph. Here the graph is a pair of vertices and edges, as simple as that. It is a pair of vertices and the edges. Here you can see it's a pair of vertices and edges. Here this is a graph. Here you can see V is a set of vertices and E is a set of edges. In this example, this is a graph because it is a pair of vertices like V, W, Y, Z, U, X, and the pair of edges, that is U to Y, U to Z, U to S, like this. Here we can see in this example, here V is a set of vertices. You can see this is a set of vertices S comma U comma V comma W comma X comma Y comma Z. This is a set of vertices, and E is a set of edges, x to s, x to s, it is a one set, one edge, x to s it's a one edge, and x to v, it is a x to v is another edge, and x to in v, it's a x to v 1 and x to v 2. There are two edges from for the two same vertices, and you can see x to u, and this is another edge, and v to w, v to w, and s to v, s to v, and s to u, s to w, and s to y, and w to y, and u to y, u to y, and u to z, and y to z. These all are the set of vertices and the set of edges. Then we can say that this is a graph. Let's see what are the other terms. Here that is the topic is subgraph. Let's see what does the meaning of the word subgraph. It means it is a sub part of the graph, we can say like that. Given two graph G and G1, we say that G1 is a subgraph of G if the following conditions hold. Means if the graph G1 is said to be, if you want to say G1 is a subgraph of G, then it should follow the following conditions. Let's see what are the conditions. All the vertices and the edges of G1 are in G. Okay. Each edge of G1 are the same end vertices in G. So let's see what does it mean. Means all the vertices are, the vertices of G1, the vertices of G1 should have in G. Means, and the each edge of G1, each edge of G1 have the same end vertices. Let's see these conditions for this example. Here is a G1 and this is the G. This is two graphs. This G and G1 and G. These are two graphs. Let's see whether the G1 is a subgraph of G or not. Let's see, apply the first condition. All the vertices and the edges of G1 are in G. Okay, means the vertices of this G1 should compulsory have in G. V1, V2, V1, V2, V3 and V4 should have in this graph G. Let's see, V1 okay present, V2 okay, and V3 okay, V4 okay. First condition is satisfied that all the vertices of G1 are present in the graph G. Let's see another condition. Each edge of G1 has the same end vertices in G. Okay, means here if you take edge V2, V1 to V2, means this is the edge, the same edge should have present in that, and the vertices also same V1 and V2. If you take this edge, the end vertices are V2 and V1. Okay, same. Yeah, another vertex, V2 should connect only to V3 and V1. So V2 is connected to V1. Okay, we already checked that. V2 is connected to V3. So the end vertices should be same. Here V2 and V3. Okay, this is also there. And the end vertices of this edge also V1 and V4. Okay, V1 and V4. Okay. And then what's of this edge V4 and V3. Okay, this is also there. So the end vertices of the edge should have same in this G1 and G. So then we can say this is G1 is the subgraph of G. Okay, this is all about what the subgraph. This is as simple as it. Let's see what is the meaning of the words connected graph. Means they should have a connection between the word nodes, and as simple as that. We can say that it's a should have a connection. Means should have the path for the vertices. Let's see what is detail. We say that a graph is said to be connected graph if every pair of distinct vertices in graph G are connected. Otherwise, the graph G is called disconnected. As simple as that. The vertices in the graph are connected, then it is a connected graph. If the vertices in the graph are not connected, then it is a disconnected graph. Means they should have a path also, they should have a path. If you can see, for every vertex there is a connection and there is a path for the vertex. If we see this in this diagram, there is no connection for the vertex 11, so there is no path for the 11, there is no connection. So this, we can say that this is a disconnected graph, this is a connected graph, as simple as that. Let's see, let's as we understand what the terms graph and subgraph, connected graph, let's see detail that what is a spanning tree. A spanning tree is a subset of the graph that doesn't have cycle, and it is also cannot be disconnected. Spanning tree is a subset of the graph, as we already know, and it doesn't have a cycle, means it should not have a cycle, and it is also cannot be disconnected, but means there should be a connection for every vertex, as I already see. Here there is a graph A, B, C, D, and the number of edges are 1, 2, 3, 4. Okay, this, when we can say this is a spanning tree, we can say this is a spanning tree if and only if it should have same number of vertices, and they should have a connection between all of them, and the number of edges should be v minus 1 edges. Means if you have v edges, v vertices, then the number of edges should be v minus 1, then we can say that this is a spanning tree. There are 4 vertices and the 4 minus 1 3 edges. Okay, A to D, A to B, A to B to C. So how many forms of spanning trees we can form for this graph? Here we removed the edge between D to C, and here we removed the edge between B to C, and here we remove the edge between A to B and A to D. Here is a formula that we can make the number of spanning forms of spanning trees by the nodes, the number of vertices. If we have n vertices, that is n nodes, then the number of spanning trees we can form from the graph is that v power, that is, sorry, n power n minus 1. If we have if we have 4 vertices, then we can form 4 power 4 minus 1 edges, 4 minus 2 edges, 4 minus 2 spanning trees. That's all about the spanning tree. Let's see what is a minimum spanning tree. A minimum spanning tree is a spanning tree in which the sum of the weights of the edges is as minimum as possible. Means here there is a graph, undirected graph. We have formed a spanning tree, and there is a cost between every edge. For every edge, there is the cost for this edge is 4, and the cost for this edge is 5 and 2 and 3 and 1. We are making a spanning tree from this graph, and the sum of the costs, there is a sum of the cost. If we compare all the spanning trees sum of cost, the spanning tree which have the minimum cost, then we can say that is the minimum spanning tree. Let's see the cost of the spanning tree. Here this is the spanning tree, and the cost of this edge is 4, and the cost of this edge is 5, and the cost of edge is 2. 4 plus 5 plus 2, that is 11. The cost of the spanning tree is 11. And let's see another spanning tree from the same undirected graph, that is 4, edge 4, and cost of the edge 1 and 2, and the total cost of this spanning tree is that 4 plus 1 plus 2, that is 7. So if we compare these two spanning trees, the minimum spanning tree is this, because it have the minimum cost. So then we can say that this is a minimum spanning tree. We are compared the cost. This is all about the minimum spanning tree. The minimum spanning trees is found from a graph is using the following algorithms. The number of spanning minimum spanning trees is the number of minimum spanning trees present. It can be from can be found from a graph by using the following formulas. Those are Prim's algorithm, Kaskal's algorithms. By using these formulas algorithms, we can find the number of minimum spanning trees we can form by using the graphs. We will discuss about Prim's algorithm, Kaskal's algorithm in next seminar. Okay, this is all about the spanning trees. Thank you. If you want to remind what is spanning tree, let's see simple. It should be a connection graph. Simple as that. It should be a connection graph, and it should have the all the vertices. The spanning tree, the subgraph should have all the vertices, and if you have v edges, v vertices, and the subgraph should have v minus 1 vertices, v minus 1 edges, then we can say that this is a spanning tree. That's all about the spanning trees. Thank you.